Alright, welcome to lesson number 2. We're talking about ellipses this time. Uh, let's talk about what an ellipse is. It's a set of all points, x, y, in a plane, the sum of whose distance from two distinct fixed points is constant. Now, that will make a lot more sense looking at it visually. You may have seen this shape before, and you might have even called it an oval. It's kind of that general idea. Okay, focus is the fixed points, right? If we have two of them, they're called foci. So we have two distinct points called focus or foci when we have more than one. Okay, the distance that these 2 points are at any given point in time always has to be the same amount. So for example, from one focus to xy, it's going to have a length and a length. If we add those, it should be the same number as if we were to add the length here and add those together. It's always going to be the same number. What a lot of people say is, imagine that you took like a pencil and you attached string to it, and you attached it to these 2 points. If you drew around those points, you'd only have enough slack on the string to go a certain distance, and that would give you your ellipse. Okay, so those distances will never change. Now let's talk about some different pieces of an ellipse. You have the center, you have a major axis, and you have a minor axis. The major always goes along the larger length, not necessarily horizontally, because remember, we can possibly turn these. Okay, the minor will be the smaller of them. And then you have the vertex, which goes on the longer ends of your ellipse. And then we have some pretty important pieces of the ellipse that we really need to know. First of all, our center has the coordinates hk. We should be familiar with those by now. Then we have some distances. Along the minor axis from the edge to the center, that's going to be a b value. The distance between the center and the focus, that's going to be our c value. And then the distance between our center and the longest part along the major axis, that'll be our a value. Thanks to the Pythagorean theorem, this being b and this being c, we know that this length here is going to be the square root of b squared plus c squared. And we end up getting this formula here, a squared equaling b squared plus c squared. So we're going to want to keep this in mind while we're doing all of these little bits and pieces for ellipses. Okay, pretty easy to work with as far as visually going. There's a formula right here. In fact, there are two. As I mentioned, you could have vertical or horizontal major axis. So let's see what this says. The standard form of an ellipse with center hk and major and minor axis of 2a and 2b respectively, where 0 is less than b, which is less than a, meaning that our b value has to be less than a. Where is this 2a and 2b coming from? Remember, a is going from the center to the edge, but if we want the full axis, it's going to be twice that length. That's where the 2a comes from. Same idea with b. So if you have a horizontal major axis, you have x minus h squared over a squared plus y minus k squared over b squared equal to 1. Very similar formula for vertical, except in this time you notice that our a and b's switch. That's what gives us the vertical major axis. So it's going to be a tall oval shape versus this one, which will be a long oval shape ellipse. Okay, so keep in mind which one we're working with. A is always larger, so whichever one of these happens to be larger, that's what we assign as A, and then it will tell us if we have a horizontal or vertical major axis. Then we have this little bit of information that tells us that foci lie on the major axis. That makes sense. C units from the center with this equation. We got that just by solving for C from that little Pythagorean theorem that they showed us a minute ago. Okay, and we're going to want that because we're not going to necessarily be given the C value. And then we might want to keep this formula in mind just because our center is going to be halfway or the midpoint between the foci. So, got a lot of formulas that we got to keep in mind. So, if you want to write those down, have them ready to go for when we start doing some problems. Here's our first example. We want to find the standard form of an ellipse having foci at -1, 3, and 7, 3, and a major axis of length 14. So, we got some stuff that we got to do. Where to begin? Let's begin with the center, because it's easy. The center, we're going to find the midpoint between our foci. So we're going to do -1 plus 7 divided by 2, and 3 plus 3 divided by 2. Let's see, that would be 6 divided by 2 is 3. This would also be 6 divided by 2 is going to give us 3. So this is our center, which is something that we need. That's going to be our H and our K. Now we need to think about what we have, right? If I want the distance between my foci and my center, that'll give us our C value. So C, I take my foci and I subtract away my corresponding center value. Sorry, I was having brain freeze there for a second. So 7 minus 3, that gives us a center of 4. Now, how did I know to use the 7? If I quickly look at what this looks like, this is a quick sketch, by the way. -1, 3, and 7, 3, right? This is where the foci are. The center is going to be in between it here. So I know that it's not going to have anything to do with my y's. And it doesn't matter if I subtract -1 minus my center, or I do 7 minus, it's going to be a distance, which is always positive. So that's where that 4 comes from. Now, they give us a major axis. They tell us the length is 14. If you remember, the major axis is the full length, which would be twice the length of A. So if I want A, we just divide the major axis by 2. Now we have C, we have A. The only thing left to find is B. Well, remember this formula, C squared equals A squared minus B squared. We know C, we know A, and we're going to solve for B. Let's see, 16 minus 49, that's -33. Those negatives are going to cancel. Take the square root. So B equals the square root of 33. Okay, so we found our center. We took a quick look at what it looks like. We can see that this is going to be horizontal. That's important because if it's horizontal, we know that our a term is going to be underneath our x. We found our c by subtracting one of our foci from our center, and we knew that we had to do it with x's because that's where the length is. Right? There would be no difference in height. We used the major axis equal to twice a, and then we plugged into this formula for b. So here it is, the moment of truth. X minus h squared divided by a has to come first because it's horizontal. So 7 squared would be 49 plus y minus k, which is 3 squared, divided by b squared. If we square this, we get 33, and that's going to equal 1. Remember, the formula said to square a and square b. That's why we got rid of the square root, and that's a 47 instead of a plain old 7. I mean, a 49 instead of a plain old 7. Whew. I'm saying a lot of the wrong things here, guys, but doing the math correctly, which is good. So try this one out on your own. Pause the video and press play when you're ready to check it. Alright, let's see how you did with this. They give us foci at -3, 3 and -3, -1. And they give us a major axis length of 10. So let's start right away. Let's see what this looks like. -3, 3 and -3, -1. That gives us a vertical axis, major axis. So we know when it's vertical that our a term is underneath the y term. That's going from our formulas. Hopefully you have those in front of you. Last time we tried to figure out what the center was first, right? It's going to be in here somewhere. So the center, that's going to be -3 plus -3 divided by 2, and 3 plus -1 divided by 2. Let's see, -6 divided by 2 is -3. 2 divided by 2 is 1. So this is our center. That's our h and our k. We got to change the signs, obviously, when they get plugged into the formula. Now, the difference here would be happening in y. So I'm going to take, for c, I'm going to take 3 and subtract away 1. All right, 3 and 1 are my y's. That's where I'm going to have a difference here. So my c value, we get 2. Now we'll look at the major axis. We know that we have 2 lengths of a for the major axis, which is 10 units long. We're going to divide by 2, which gives us an a value of 5. Now we're going to plug in to this formula. Right? 2 squared would be 4. 5 squared would be 25. We'll subtract 25 from both sides. So -21 equals -b squared. Those negatives are going to cancel out. Take the square root. So b is the square root of 21. Alright, so we've got a lot of good things here, right? We've got our center, we've got c, which we don't really need for the formula, but it helped us find a and b. We also know it's vertical. So when we write this, we want to have x minus h, so that should become plus 3 squared. But because it's vertical, we want the b value squared to be underneath. So 21. Then we got y minus k, which is 1 squared. We want our a value squared, so 5 squared is 25, and that's always going to be equal to 1. Hopefully you got that. Really, again, not necessarily difficult math, it's just a lot of different things you have to do. And it's always like, alright, where do we start? Once you get started and get the ball rolling, hopefully they get a little bit easier. Let's take a look at sketching some. Alright, I actually enjoy sketching them. They're kind of fun to draw out. Pretty easy to do. They want us to sketch an ellipse that has the equation x squared plus 4y squared equals 36. Now, we're actually in some pretty good shape right here because really all I need is for this to be a 1 and we've got everything we need. Alright, we have our x squared and our y squared. So here's what I'm going to do. I'm going to divide everything by 36. That's going to make that a 1. X squared divided by 36. Here I can reduce, right? That 4 and 36, that reduces to 9. So now I have plus y squared divided by 9, and my 36, I changed it into a 1. That was the whole point of dividing by 36 in the first place. Now we're looking even better. Right? This and this would be A and B. Remember, A is always the larger term. I want to see what that is in terms of A squared. Right? So I'm going to change that. 36 is really 6 squared. And I want this in terms of B squared. So I got y squared divided by 3 squared. Right? 9 is 3 squared. Now we have our A, our B, our center. We're not adding anything to x, so that would be 0. Not adding anything to y, so that would be 0. And because our A term is underneath x, this is horizontal. Why does that matter? I'll tell you in a second. All right, we've got our center. Let's talk about the vertex. The vertex is going to be A units away from the center, and it's going horizontally, which means that everything is changing in the direction of x. So I've got to add 6 to both, not to both, but in both directions, we've got to add 6. So if I head in the negative direction from our center, that would be -6, no change in y. And if I look at my other direction, I'm going to be adding 6 with no change in y. So this is where our vertexes live. Graphically, our center is at 0, 0. Our axis is horizontal, so we know all of the major height is going to be going this way. The A length, which is the center to the edge, is 6. So I go out 1, 2, 3, 4, 5, 6 units. That's where that 6, 0 came from, and 6 in the negative. That's where the negative 6, 0 came from. Then we can also talk about the minor axis, because remember, the minor axis was from the center to the ellipse itself. That was the B value. B here is 3, so if I go up 3 units from the center and 3 units down from the center, we basically have the outline of our ellipse ready to go. All we have to do is connect these dots. And now we have our ellipse, right? We knew the major axis was horizontal, that associates with A, so I went 6 units in both directions from our center. That was where our vertex comes from. We also know the minor axis is our B value, which we found right here to be 3. So from the center we went up 3 and down 3. Once we have those 4 points, we draw that ellipse. This is a really nasty looking ellipse. I'm sure that you can probably draw them a little bit better. So why don't you try that here on this problem. Pause the video and resume it when you're ready to check your solution. Alright, did you start off by dividing by 25? Because that's what I would have done. In fact, that's exactly what I'm doing. Right, the 25s are going to cancel here. So let's see. That means that I have x squared divided by 1 plus y squared divided by 25 equal to 1. I want to know what that is in terms of a and b. This is going to have to be my a because it's larger. 1 is really 1 squared. That's my b term. A rather, would have to be 5 squared. That's what 25 is. Right? So we've got our a, we've got our b. Our center is still at 0, 0. And I can see that this is going to be vertical because my a term is underneath y. So let's plot our center first. Everything's changing vertically. So I need to go up 5 from my center. And I need to go down 5 from the center. That's going to give us vertex at 0, 5 and 0, negative 5. Our B, our minor axis, so that would be going left and right. I have to go 1 unit in both directions. 1 unit left, 1 unit right. So this is a really skinny ellipse. And there you go. Good news. One more page. This time, though, they're not looking quite as friendly. But we're going to use completing the square, just like we've done pretty much every time that we come into contact with an x squared. So this shouldn't be any shocker to anybody out there who's seen anything that we've done in the past. We're going to be using completing the square. So let's do it out. We want to group our x's together, group our y's together. So we want 4x squared minus 40x. We'll group that up. Plus y squared plus 4y equal to negative 100. I already said it. We got to do completing the square. But before we do that, I'm going to factor out a 4 because I can't do it on something with an a term on x. So we got to factor. That 4 comes out. That would give us minus 10x. Now I can do the completing the square. Negative 10 divided by 2 squared. That's really negative 5 squared, which is 25. So I'm going to be adding 25 in here. But we're not adding 25 to this side. We're adding 4 times 25 to this side, which means that I have to add 4 times 25 to this side. So 4 times 25, that's 100. So we're adding 100 to this side and this side alike. For my y, my b term is 4 divided by 2. That's really 2. Both of those will be squared. So 2 squared is 4. That's what I'm adding here. I only have a 1 out in front here, so I'm adding 1 times 4, which is only 4. So that's what's being added to this side. So negative 100, positive 100, that cancels out. We've still got this 4 right here. I'm going to simplify this. We just use completing the square. So 4 times x minus 5 squared. Going to do the same thing here. Y plus 2 squared. And all of that equals 4. Now we're almost there, right? We have x and y all in the parentheses. We just need this to be equal to 1. So if we divide by 4, I'm going to do that to each piece on this side. Now I notice that my 4 goes away here. That's really a 1. So here it is. Here's our equation. X minus 5 squared over 1 squared, right? 1 squared is really 1. Then we got y plus 2 squared. 4 is really 2 squared. And that we reduced to 1. This is the larger one, so this is A. And that makes that B. That makes this vertical, because A is under Y. We got basically everything we need, right? Our center is going to be at positive 5 and negative 2. So positive 5, negative 2 is here. Our A, which is vertical, I got to go up 2 units and down 2 units from our center. Our B value is 1, so from our center I go left 1 and I go right 1, and then we connect. And there's your ellipse. So really not bad, right? You group together. If you need to factor something out, go and factor it right away. Use your completing the square. Just be careful, right? If we do factor something out, what we're adding to that side is not just the number itself, but that factor times to both sides. Okay, then we reduced, divided by whatever it was we needed to get rid of that to make it a 1. We figured out if it was vertical or horizontal, and then we graphed it from the center using A and B. It's a process, but it's not difficult to do. So try this one out, pause the video, and resume it when you're ready to check, and then you'll be done with this lesson. So, I told you group together to begin with. So let's see, x squared minus 6x, 9y squared plus 18y equals negative 9. I don't have to worry about factoring here, but I'm going to do the completing the square on that negative 6. So negative 6 divided by 2 squared, that would be negative 3 squared, which is 9. So I'm adding 9 here. I didn't have to factor anything out. I'm just adding plain old 9. So I'm going to add 9 to this side as well. I've got to factor out 9. So that becomes plus 9y squared. If I factor out 9 from here, that's plus 2y. Alright, 18 factor out 9 is 2. So now I've got to do completing the square on 2. 2 divided by 2 squared is really 1 squared, which is 1. So I'm adding 1. But what I'm adding overall to this side is 9 times 1, which is 9. Negative 9, positive 9, that cancels out. So here's what we've got. X squared minus 6x plus 9. We can reduce that to x minus 3 squared. That was the completing the square trick for x. Plus 9 times y squared plus 2y plus 1. We can change that to y plus 1 squared. That was the completing the square trick for y. On this side, we have equals 9. We've got to divide by 9 on both sides to make this a 1. These 9's reduce, that becomes 1. So x minus 3 squared. 9 is really 3 squared. Oops, that's a plus. 1 is really 1 squared. This is my A. This is my B. That means this is horizontal. We know our center is going to be at opposite, so positive 3, negative 1. 1, 2, 3, negative 1. That's our center. I've got to go 3 negative and 3 positive from the center. And our height, or minor axis rather, I guess, is probably more accurate. It's 1 from the center, both directions, and then we connect. Alright, that's it for ellipses. Again, really not that bad. It's mostly a lot of the same kind of stuff we've been doing, a lot of completing the square, so hopefully you're confident with that trick. That's really it for ellipses. We've got one more conic section to talk about. It's going to be hyperbolas. That's coming up next. And then we get to talk about things called polar coordinates. So we've got some pretty cool stuff coming up to cap off our pre-calculus course. All right, I'll see you at the next lesson.